been a little while since I've seen you. Time is of the essence, as they say. It does, and it fruit flies like a banana. That's right. Okay, so just a couple quick things, and then we're going to jump in and get started with our lab today. First of all, it's National Random Acts of Kindness Day, so do something nice for somebody. Find somebody to do something nice for. Do it. A couple of things. So last week was a little bit goofy. Last week we had that snow day, and then we had the late start day, and it kind of threw a lot of things for a loop. And like it or not, we just have to keep on trucking, right? End of trimester is next week. Holy cow! So we gotta keep cruising. So let me just give you a little peek at what is coming and what to expect. So Thursday was a snow day last week. We worked on moment of inertia, problem solving, and conceptual and computational problems. Okay, I put all of that up on Canvas. This is just a screenshot from Canvas. There was a video that I made for you, okay, that kind of walked you through some things. There was a problem page with some ranking tasks on it. There are some problem solving problems. There were 3 of them. And then, yes, or on Friday, a couple people requested that I make some video solutions. So I did that on Saturday morning, and they are right here. So that is stuff that you should have already gone through. But if you haven't, you still can, right? It's not like the opportunity is lost. Like, it's still there. Make sure that you've done that, okay? Friday was a 2-hour delay, so it was a shortened day, which is fine. I still got to see many of you, but we only had this much time, and we needed about this much time. So if you were not here on Friday, that was Valentine's Day, here is the video for the lesson. So again, this is a screenshot from Canvas, right? A video for the lesson in class. So make sure that you watch that if you haven't already, okay, or if you weren't here. And then I also made a follow-up, which was like the last 10 minutes of the conversation that I wished we had time for in class, but we just didn't have time for because the bell rang, okay? And then there were some practice problems associated with this rotational kinetic energy stuff, and the problems are here, and then videos for each of them is here as well. I did notice, because I was making sure that all the links worked, that many of you have already watched some of this stuff, but if you have not, like if you have not yet taken the opportunity, make sure you do, okay? This week, we're gonna do a lab for a couple of days. This is gonna be a lab where we do a full analysis, okay? So I just want you to be aware of that. It's a really great lab, but it is one, just set that up there, thank you. It is one where you're going to need to make sure you're like all in, all here during those times, okay? On Wednesday, we're gonna talk about angular momentum and angular momentum conservation. Thursday, we might do an applied problem. We might just do some workbook problems. I haven't decided for sure, but I think I'll probably get those to you, I don't know, maybe tomorrow. And then Thursday is our review day. We're taking a test over Unit 7 on Friday, okay? If you choose to do corrections, I'm just kind of heading this off ahead of time because some of you are still doing corrections from Unit 4 and Unit 5 and all that kind of stuff. Just a heads up, all of those corrections from the Unit 7 test, that's what we're gonna take on Friday, have to be done by the following Friday. Does that make sense? Because that's the end of the trimester. That's gotta be it, okay? Monday and Tuesday of the following week, so a week from today, we're going to be reviewing trimester 2, just kind of going over everything that we know. And then on the 26th, that's our finals day. Science is the first of the finals. It's like science and electives, I think, happen on the 26th. And that day we will be taking a, however long that period is, version of the multiple choice of the AP exam as well, kind of like we did last time. It will be over everything we've covered up till this point, okay? So trimester 1 and trimester 2 stuff, because we're adding it and adding it and adding it because May 7th is coming, and on May 7th, we're gonna do all of it, okay? Does that make sense? Questions that you have over this information? I know there's a lot there, and I don't wanna overwhelm you, but I also want you to be aware of what we've got ahead of us. We good? Okay. If you need any help, let me know. Right now, Mr. B is teaching all of my regular physics for the rest of this week. So if you want to come in and chat with me one-on-one or two-on-one or whatever, I am basically open all but 6th and 7th periods this week, okay? So you let me know when you want to come hang out and we'll go into one of the offices and we'll do physics, okay? So I'm here. I love doing physics with you, so just let me know. Issues or questions with this before we move on? Okay. So today we're going to do a lab. I'm going to hand the lab out to you real quick. No, I'm not. I lied. We're going to go look at the lab first. So I'm going to meet you right over here. You guys can meet me on the side. Hello, you guys got here just in time. Here, two of them. So you all know that one of my favorite parts of AP Physics is that not only do we get to do the lab, not only do we get to ask how does blank affect blank, but we get to dig in and figure out really how do they affect each other. And we get to figure out what this data should look like and how we can get it to be a line that means something. So this is the setup. The picture that I have up there I had stolen from a colleague of mine named Connie Wells. She is the one that designed the lab, but I like this picture better just to give you a sense of what's going on. Okay, I got to move fast here because I know that bell is going to interrupt me fast here. So just a couple of measurements that we might make. I label this, oops, I'm going to make that a small r just because I usually write it as a small r, R2, and the distance right here, oh, you can't see it, I'm sorry, there you go, is R1. Oh, whoa, hi, there we go, is R1. So there are two masses, or two mass measurements. We've got mass 1, that's the hanging mass, that's the one that's coming down off of my pulley. And then I've got mass 2, each of those single masses that's taped on the crossbar. Okay? So I just want us to spend a couple of minutes looking at the theory behind this so that tomorrow after you've taken your data, you can start jumping in and trying to linearize this data and figure out what's going on. So let me walk you through a couple things. We have to figure out how some variable affects angular acceleration. You're going to measure angular acceleration by measuring the time and the distance and finding acceleration. But we want to figure out the rest of the relationship here. Fastest way to do this, best way I know, is to start with an F-net equation for mass 1. What forces are acting on mass 1? Tension, which way does tension go? Up? Not trying to trick you. It's okay, and I'm just going to write it as FT because I'm going fast. But you're totally right. Tension goes up. What else you got? Gravity. And which way does that one pull? Down. Which one's bigger, the tension or the gravitational force? Gravity, how do you know? Because, yep, it's accelerating downwards, right? So FG is bigger. And I can write F net in the y direction is equal to, well, it's FG, negative FG, plus FT, and that equals the mass 1, because that's the mass we're talking about, times its acceleration. Okay. I could solve this for FT, and I'll show you why in just a minute, but I'm just going to do it right now. FT with, oops, and this has to be a negative mass times acceleration. It's accelerating which way? Down, yeah. So I've got FT is really going to equal FG minus M1 times A when I move that FG over to the other side. Okay. What is FG? What is it? The force of gravity, right? How do I calculate the force of gravity? Say it loud, guys, you know it. MG, 9.8 times the mass. Which mass is it? Mass 1. So this is really M1 times, I'm just going to write this as G minus A. Is that okay with everybody? That's FT. Good for us. All right. Now, that acceleration is not just dependent on this mass, but it's also dependent on that tension. And that tension is kind of dependent on, well, what else is going on over here, right? We've got some rotational stuff going on, which means that we've got some angular acceleration. How do we mark angular acceleration? Alpha. And we know from Newton's second law that alpha is equal to what divided by what? Do you remember? Say that one more time. Delta omega over t. It's true. I agree. 100%. But that's not the one I was thinking of. There are lots of different. I love it. Thank you. Yes. I want a Newton's second laws version, though. That is the definition of alpha. What does Newton's second law say? For translational motion, it says that acceleration is mass divided by, or excuse me, force divided by mass, right? F equals ma, a equals f over m. What does rotational accelerations, Newton's second law, say? What is it? torque net divided by, what is it? What's that thing? Yeah, it's the moment of inertia, right? Yeah. Torque is force times distance. Is there a force causing this thing to rotate here? What's causing this thing to rotate? There's a tension force, right? There's a tension pulling a little away from that axis of rotation. If we look from top down, just at this little part here, it would look like this, and then that string would be pulling like this, Ft, some distance away from the axis of rotation. Okay, so that's exactly what we've got here. So we've got a force, Ft, times a distance. The distance away is R1. Okay. Moment of inertia has different values depending on what it is. We're going to call it just 2 point masses. Again, we said that bar is massless. It's not really, but we're going for it for now, okay? Because it's going to make our life so much better in the long run. So we've got 2 of them, and each point mass is what times what? Somebody said it earlier. Do you remember how you find the moment of inertia of just a mass a certain distance away? mr squared, yeah. So that's going to be mass 2 times radius 2, whoops, squared. How are we doing, team? Are we okay? So this is the F-net equation dealing with mass 1. This is the alpha equation, the torque equation, dealing with that whole system, this stuff up here. 2 equations, 2 unknowns. I want to know how something, M2, R2, or M1, affects what? Do you remember? What was the question that we were asking? Rotational acceleration alpha, right? So I'm going to take this mess and I'm going to put it right in here for Ft. Okay, so here it comes. Here we go. It's going to be a good thing. Here it comes. So we're going to say alpha is equal to M1 G minus A times R1 divided by 2 M2 R2 squared. Okay. There's an A in there. We don't want an A in there. But is there a relationship between A and alpha that we know? Yeah. What is A equal to? Do you remember? A is equal to alpha times R, and in this case, it's alpha R1. So instead of writing A here, I can write alpha R1. And now I have got a really, really ugly fraction that includes all of the things I've measured and all of the things I'm using for variables for both my independent and dependent variables. Okay? I would like to task you with the goal of trying to make this a linearized equation. I will warn you that it's ugly. It is not something that I would expect you to do on a test, but I think it would be worth giving it a try. Spend 10, 15, 20 minutes on it today sometime before I see you again. See if you can get this thing to look like y equals mx plus b, where this involves alpha, this involves your independent variable. So that'll be different for different people, okay? And all of the rest of it is constants that live in M and B, okay? Give it a try. You'll need some more paper. Mine is right here. It took me this much space, okay? I write kind of big, and I kind of space it out, but I just want you to know that that's what's going on, okay? That's your goal, is to linearize this equation, okay? Tomorrow you will take data, finish taking data, and then you will start setting it up. I'm just giving you one more day in class to work. This lab will be due, finished by, I don't know, Thursday sounds like a good time. Okay? All right. The bell's going to ring in just a minute. You have time to get started if you want. Don't give up. Don't quit. Or don't whine to me tomorrow if you can't figure it out. Fair?